Good afternoon, students. From the previous class, we may completed with the N-type semiconductor and P-type semiconductors, right? So today, we are discussing with some example problems, and we are started with the new one. Okay. For the last class, we are completed one example. Let us now started with the example 2. Okay. So try to answer this one. So which one of the following statement is false? So once again, you just recollect the points of N-type semiconductor and P-type semiconductors. Okay. So last class nadathatha just a review parunga. Paathutu you have to answer this question. Okay. So here they are given 4 options are pure silicon. Silicon is doped with trivalent impurities and gives a P-type semiconductor. And B, here the majority carriers in N-type semiconductor or holes. Okay. In third one, minority carriers. Minority carriers in a P-type semiconductor or electrons. And D, the resistance of intrinsic semiconductor decreases with decrease in temperature. Decreases with increase in temperature. So this is the question. Okay. So let us now, from the previous class, I may given one table, no? Write it the majority carriers and minority carriers for N-type and P-type. Right? On that, we have a clue that N-type for the N-type, N stands for electrons, the sound, the electrons. So N-type, the electrons, it should be the majority carriers. Okay, so automatically the minority carrier will be holes. Right? For the P-type, it is positive P. So positive P அப்படிங்கும்போது electrons having a negative charge and holes having positive charge. Right? So positive charge P represents the holes. So that is the majority carriers. Okay, P type la majority carriers, it should be holes. And the minority carriers, it should be electrons. Okay, so it is clear. So இதை ஞாபகம் வச்சுக்கணும். So இதை ஞாபகம் வச்சுட்டு you can mark the correct answer. So which one is the right one? You have 1 minute time. Okay. You just try to answer this one. So here we have noticed that which statement is going to wrong. Okay, wrong statement that you have to find out. So here for the N type, okay, so the majority carriers will be another. It is the electrons. Okay, so the correct statement la electrons varano, but enna kuduthirukanga here it is the holes. Okay, so that is the wrong one. So here option D is the right one. So it is able to follow. Yes. Next, third question. If a small amount of antimony is added to the germanium crystal. So here they are given 4 options. It becomes a P type semiconductor, and B, the antimony becomes an acceptor atom, and C, there will be more free electrons than holes. In the semiconductor. And option D, its resistance is increased. Okay. So you may have 1 minute time. So try to answer this one. So here we have noticed that antimony. Okay. So antimony is a trivalent or pentavalent? Trivalent or pentavalent antimony? Yes, it is a pentavalent. Okay. So here germanium. Germanium having 4 atoms in the outermost. Okay. So it is a tetravalent. Okay. So if it is added to the germanium crystal, automatically it is a N-type. Okay. Automatically it is a N-type semiconductors. Okay. It is a N-type semiconductors. Right. So for that N types, which one is the majority carrier? Which one is a majority carrier? For the N type, which one is the majority carrier? Either electrons or holes. Electrons. Very good. Right. So electrons or the motions, it will induces the current, right? So here there will be more free electrons than the holes in the semiconductor. So by N times semiconductor, which one it should be maximum? Electrons. Holes of the electrons, it should be maximum. So the option C is the right one. Okay. So here there will be more free electrons than the holes in the semiconductor. Okay. So option 3 is the right one. C is the right one. Okay. It is clear. So here option C is the right one. Next one, we can go for one problem. Okay. So write down the problems first. Pure silicon at 500 Kelvin has equal number of electrons. Electron, that is N into E, and hole, it is N into NH. Okay, so that the concentrations they are given. Concentrations of both of them it is 1.5 into 10 power of 16 meter power minus 3. Okay, so here they are adding the indium as a dopant. So by doping by indium increases NH to 4.5 into 10 power of 22 meter power minus 3. Okay. So here we have to find out the value of Ne. Okay. So the doped semiconductor is what? So the doped semiconductor is of what it is. Okay. So here the option of A, it is equal to Ne value. You have to find out. Ne value is equal to 5 into 10 power of 9 meter power minus 3. This is one option. Then option B, it is Ne is equal to 5 into 10 power of 22 meter power minus 3. And option C, it is 2.5 into 10 power of 10 meter power minus 3. And option D, Ne is equal to 2.5 into 10 power of 23 meter power minus 3. Okay. So the 4 options they are given. So here you may tell me the given values. Okay, what are all the values they are given? First you have to think it of. Okay, right. So first, yeah, pure silicon they are taken, right? So it represents the P-type semiconductor. Okay, so the P-type semiconductor is obtained when silicon is doped. Silicon edoda dope pandrom. It is doped with nammaloda germanium or aluminum, boron, indium. Edu kuda venalum we can dope. Okay, so the trivalent impurity edu kuda venalum we can add. Okay, so add panna அப்படிங்கும்போது silicon வந்து it will act as a p type semiconductor. Okay, silicon or germanium in the 2 atoms, so we can add with the trivalent impurities. Say for example aluminum oda we can add. Okay, boron oda we can add, or indium oda we can add. Edu kuda act aanalum it will act like a p type. Okay, so p type semiconductor it should act. So inga silicon நம்ம இதோட dope பண்றோம். A silicon here. Okay, if it is doped with our indium. Okay, so automatically it will act like a p type. Okay, so the p type semiconductor it should act. So இத mind la vechukkom. Okay, so here they are given one clue. Okay, so equal number of electrons and holes. Okay, and their concentrations. So equal number of electrons and holes அப்படிங்கும்போது we have to take it into account, that is the Ni value directly they are given. Okay, Ni value they are directly given. For Nh value is also given. Here it is. Nh value they are given and Ni value they are given. Okay, and they are asking only for Ne. Ne oda values நம்ம find பண்ணனும். Okay, so for the p type we are having one formula. என்ன formula? What it is? என்ன formula யூஸ் பண்ணலாம் இந்த sum solve பண்றதுக்கு? You may have any guess? Last classல பார்த்தோம் இல்லையா? Ni square is equal to holes oda number of electrons plus electrons oda number of electrons we have to multiply. அவ்வளவுதான். holes Ni concentration க்கு square பண்ணிட்டு இந்த ரெண்டு values-யும் நம்ம multiply பண்ணிக்க வேண்டியதுதான். Okay, so that is the formula. Here we can use the formula that is Ne into NH is equal to Ni square. So in the formula da number use panna porom. Okay, so here we have used the formula that is this one. So problem la what are all the values they are given. Okay, so given values first we have to write. Okay, so Ni value is equal to 1.5 into 10 power of 16 meter power minus cube. Okay, then NH oda values